So let's first, I would like to give a short introduction about myself. My name is Tushank and I am a Python developer who loves to code in Python and build backends using framework like Apache and Flask. Today, I had been selected to conduct a short session on Python organized by the Monkeys team. So let's begin with our first topic, that is Python philosophy. So in Python philosophy, we have the Zen of Python, that is a PEP 20 also. The Zen of Python is a collection of guiding a person for writing Python code that is authorized by same patterns. So here are 20 patterns. We don't deep down in this topic. If you want to like learn or solve the Zen of Python, then you can go directly on the documentation. Second part is our Pipet. Pipet is the official Python style guide. Like it exists to improve readability and consistency of Python code, like across projects and teams. We have six to 7 points in Pipet, like code layout, naming conventions, import guidelines, spacing rule, comments, documentation, function and class definition, and common pitfalls to avoid. We have also a documentation for a Pipet. Uh, Here it is. So you can reach out it. Now, third topic is our quarks and arcs and quarks. Now, arcs is our like variable position argument and quarks is like variable keyword argument. Uh, in arcs, like arcs is only a variable, only a value. Let's you pass any number of position argument to a function. So like we saw that uh, in this function we can use we can use args and pass the two values. So the output is like 5 because this sum of the args, and these are the some examples. And for quarks, like we can we can pass in like dictionary format, or you can say as like object format in key and value pair. So here it is. If we can mix both args and quarks and like normal values in a single function, then in this function, we have title, args, and quarks in the parameter of the function, and we can pass detail is go in the title parameter, extra one and extra two are go in the args because it is only a value, and a is equal to one and b is equal to two go in the quarks because it is it is passed
These
in
are named
the
values only.
dictionary format.
Yeah. Okay.
And now we have saw that like unpacking some there are some unpacking tricks, like for list unpacking we can unpack like using arcs style. So here it is like one, two, and three, and like in for dictionary format we can use unpack like in quarks uh, for style. So like here it is, and we also have function argument unpacking. So uh, in this we can unpack in arcs style. So like, and here is a like twist, like what if I pass a list versus individual value? Here in this topic, this is a uh, made point. Like in this, it will it will count in a in a different manner, like one, two, and three. But if I pass the whole list, it will only count as a one, as a single value in quarks. So this is a sort of basic functions. So like second function we have typing. So like typing shall document what type of variable, function parameters, or return value should be. They don't enforce like type at runtime, but help with code clarity, tooling, and auto completion. Like these are uh, the example. Like this is the without type string, without type hint, and this is with the type hint. In the difference between both of them, that we can recognize that what type of value we want to pass in the parameter. So here are like some complex type hints. Like first we have like union. Union basically take multiple possible types. Like use union when a variable or parameter can be more than one type. Like as we saw that in this, we have int, float, or string type of value pass in the parameter. Second one, we will have like optional. Optional is a like a single particular type, or it is a none. So in this, it will we can pass the string, or on the other hand, uh, it will be none. And the third one, we have like type dictionary. Like basically type dictionary, the structure of dictionary with specific keys and types value. Like we can, if I can relate this, this is a like pedantic model in a fast API. So we can give the type hints, or different type hints to the different keys, and it comes like this. Like we on a single hand, like we have like a string value in the email, otherwise it will be none. And some like this is a like basic type hints like list, people, and dictionary. Like list have string values, all string values. People have all int values, and dictionary have like string and int values. And like uh, next, our next topic is a context manager. Like a context manager is a Python construct that allows you to set up and tear down resources properly, ensuring the resources are like cleaned up. Like context manager typically uses the with statement. They will they help manage setup and clean up logic automatically, ensuring that cleanup happens even if an execution occurs. And like this is the example of without context. In this, you manually need to call file.close. But if an error occurs before that, the file remains open. And if we saw the with statement, the with statement simplifies resources management by automatically calling a context manager, enter and exit method. We can use in this example, we can use with with the context manager. In this, open is a context manager, and that automatically closes the file after the block of code is executed. Now, how do context manager work? Like it works basically on two special methods. Like first is a enter, and second is a like exist method. So like that's all from in this topic. And like next topic is a generator. Like uh, Like a generator is a special type of function that produces like values one at a time using the yield keyword instead of returning them all at once. So like we have compare the normal function versus generator function. Uh, in this, without if we saw the normal function in this calling number return the whole list at once. But in the other hand, if we saw the generator function, it only returns object which yields value one at a time as you iterate. It will, and if I uh, also call at one time more, then it will automatically call stop iteration in generator. And like how generator works, like each to call to next resume, like next resume the function from where it left off. If it left off, it remembers the internal state and it stops when the function end or the iteration is reached. So like in this, as we saw earlier, that it will raise a stop iteration. And there is a there is a lazy evolution also. Lazy evolution means value are compared only when needed, not all at once. This generator never ends, but it is safe to use because it only computes one number at a time. It is useful when working with large data sets, file reading, streaming data, and etc. Like it is a infinite loop function, but it is still safe because it don't return huge amount of values. It only return the values we call when we call, and it only return a single value at a time. Then we can see the memory comparison between list and generator. This is list stores all values in memory, but generator calculate on the fly. And that is a memory efficient. So in like it is a loop of 1 million numbers. So like it takes high memory usage, but in generator it takes very low memory usage. And we also there is a like key point. In generator we have two yield. First is yield and second one is yield from. Yield from is for delegating to another generator. Yield from is used to delegate part of a generator operation to another generator or iterator. Like it, uh, it will be it will be depend on the other generator function. So this is a like yield from example. And now we have a memory efficient code the topic that we have some question in this like what happens when we store millions of items in a list, or what if we don't even need them all at once. Like I will explain that memory matters in large scale, but in Python provide tools like generator slots. Generator is to avoid loading everything in memory, and slots to make custom objects lighter. Like custom objects lighter. So like in this, we already see this that it will store the values in the memory, so it takes memory more than. But yes, we will see that how much it take memory in the memory memory management. If we can pass it, if we pass in the list comprehension, that it will take approx 8 to 9 MB or more for 1 billion values. But in generator comprehension, it will only take typically 112 bytes. We can sort that using SYS uh, package. And like these are the use case like processing huge files, working with API or data streams, saving RAM when handling large data. So like yield line dot strip, like this is reading the line of code in the different file one by one. Now this is the main part that in Python we have also slots for memory efficient classes. By default, Python stores object attributes in a dynamic dictionary. and this is flexible but waste memory when creating many objects. Slot restrict attributes and remove the dictionary, saving memory. But in the class, we know that all the, the all the methods are stored in the dictionary format in memory. But if we can have multiple instance of an object, then we can use slots for memory efficient code. And if we use slots and then we call the dictionary, it will raise the attribute error. So like there is a real life example also, like list like pre-cooking all meals and putting them in the fridge, like fast access but takes spaces. Generator is like cooking only when needed, slower but saves memory. Normal class like a person carrying a large bag for unexpected stuff. But for slots classes, like someone carrying only the essentials, so it is a lighter. So now our next topic is like anti-pattern. Anti-pattern. Like anti-pattern is a common but poor coding practice that might work but leads to bugs, performance issues, poor readability, difficulty maintaining code. So this is like some basic comparisons to clear the anti-patterns, or like what is anti-patterns or what this stuff. So in this, we can use list in the parameter and pass the values. But that we can saw in this, if we can pass one, then it will return one. But but the second time when I will pass the second two value, then it will return one and two. But if we can use type hint and give a none, uh, so it will only return one or two. It will don't store like one or two. So like second is for importing, like from math import all the parts. But like if we use square root, then I can use import math and that method dot square root. And writing in this, like writing over complex one linears, like in this we can use list comprehension. Also we can check the conditions of the value, so it will like split the logic for clarity. We can also check the values in the return state, and we can only pass using this comprehension there to split the logic. And in this, like ignoring exceptions for catching too broadly. So like if this is like solves all error even bugs, but it will handle like proper exceptional cases that we handle. Like in there is like repeating code, no abstraction. So like in that format, we can use and take same in the two variables. But here I am using one function and take as much as I want in the variable. So like second is overusing like global variables. Like the better use case is like use functions parameter or use classes with instance variables. So like in this, like we can use for useless for global variable. In this function, we can also use like here it is like count variable in the parameter. And like last example is like not using constant context manager. Like in this, we can call it and use it for manually. But with this, we can use with the statement and open context manager for this. So it will handle file close also on their end. So like last next topic is our like memory management. So like in memory management. In Python, memory management is mostly automatic, but to write efficient code, we should understand how Python allocates, tracks, and free memory behind the scene. Like the main components of the memory management are like reference counting, that is a core mechanism. Second is like collection that handles cycle. Third is like two tools. There are two tools, SYS package and GC package. The SY and the last one is like for optimization, we can use slots in the oops. So like now we can see the reference counting in this every Python object keeps to track how many reference points to it. Like one reference count drops to zero. Python frees the memory automatically. It will refer to and like second one is like garbage collection. Like reference counting fails when two or more objects reference each other, like in circular reference. But Python handles this without garbage collector. Here it is like we can A dot B is equal to B and B dot A is equal to A. It is called a circular reference. Even if no variable reference A or B, their mutual reference keep them alive. That is when Python GC modules come in. Like GC module is used for detect and collect cycles. In the GC dot collect is used to manually trigger collections. GC dot get stats used for GC performance stats. Dot garbage used for uncollectible objects like it is rare. And the use case of GC module is debugging memory leaks. Memory manual collection is in long running apps. And now we have sys.get reference count that explore reference counts is used to see how many reference exist for an object. So like often is like one is due to temporary reference. Like the gotcha is like it returns count plus one because the function itself creates a temporary reference. So it is always a one in the memory. Now, next is like memory leaks from circular reference. Like in older Python version, before GC was mature, circular reference caused memory leaks. But now the garbage collector usually cleans them up. But in large apps, uncollectible objects can still leak memory. Like always break cycles manually possible. Like example set a dot b is equal to none, and like second one is like avoid circular reference in destructors. So we can use del which belongs gc module. And the last example is like slots reuse and reinforce. We already seen how slots can remove pre-instance saving memory when creating many objects. Like this is like some tabular form to understand. Like for memory usage, without slot, like high due to dictionary, and for with slots, it is low. But in flexibility, slots without slots, it is dynamically attributes, but with slots, it fixed attributes. So, like our next topic is like global interpreter law. Like what is the GIL? The global interpreter lock is a like mutex in C Python. That is a Python interpreter, which allows only one thread to execute Python bytecode at a time, even on multiple processors. But why does the GIL exist? But in C Python uses reference counting for memory management. Reference counts must be updated automatically. GIL ensures that without the global interpreter lock, we had need to complex set safety for all object operation, reducing performance. The GIL simplifies memory management but limits to do multi-threading. Like, what is the impact of GIL on multi-threading? Like, multi-threading in Python is limited by the GIL for CPU-bound tasks. Like, on thread, don't run in parallel, or also on CPU, on multiple CPUs, even on multi-core CPUs. Only one thread run Python code at a time. But input-output bound program like web scraping or file download can still benefit from threading. Like we have the difference between threading versus multiprocessing. Like in memory, if we talk about memory, threading shared memory, multiprocessing separate processes. Or if we saw overhead, then threading is low and multiprocessing is higher. I think yeah, is higher. And if we can saw GIL on multi-threading, then there is no uh, and multiprocessing for yes run in separate Python interpreter. And what is best for like if we have input output bound tasks, then we can use threading. But if we have CPU bound tasks, then we can use multiprocessing. Like we have some examples on GIL. First, we have saw input output bound. Like in this for this code, the it runs in like similarly precisely 2 seconds, not 10 seconds. Thread wait for input output to complete, and GIL is released during sleep for on this line. And if we saw the CPU bound task, like for example Fibonacci, then it takes almost the same time as a single thread, and GIL prevents true parallelism. And if we compare it with multiprocessing, then it runs faster because multiple cores used in this. Like we compare threading versus multiprocessing on CPU-bound tasks like Fibonacci and observe that threading does not help due to the global interpreter law, while multiprocessing achieves real parallelism using multiple cores. Now, like Python GL ensures only one thread execute at a time. It helps with memory safety, but prevents CPU-bound threads from running in parallel. For output bound, like file or network, Python releases the GIL, so threading helps. But for CPU-bound tasks, use the multiprocessing module to bypass the GIL and fully utilize multiple cores. And this is a like close with key takeaways. Like GIL is not equal to bug. It is a trade-off. And second one is we can use threading for input output bound. And on the other hand, we can use multiprocessing for CPU bound tasks. This is a architectural design like between async versus thread versus multiprocessing. So like we have some situation and best approaches and why it is good or not. Like first situation is like input output bound. Like for example, like API calls, database reads, file input output. Then best approach is for is async or a threading because input output releases the GIL. Async scales better for thousands of tasks. And second situation is CPU bound tasks, like for example, image processing, heavy math. So for that, we can use multiprocessing. Because it avoids GIL, runs on multiple CPU cores. And next one is like few blocking input output tasks. For that, we can use threading because simple to write, good for less than 100 threads. And last one is like high concurrency with low memory. So we can use async because it is efficient, scalable, few operating system threads. Like there is a small note for like Python gives you thread processes and async. Chose based on your task, thread and async for input output, processes for CPU, and GIL affects CPU threads but not async or input output threads. Now that's all from my side for the session. If anyone has any question related to the session or Python, I would love to hear them. If I know the solution, I will share it with you. Otherwise, we can explore and learn it together.